A buffer is made by mixing zero point 0.9 moles sodium acetate and zero point 0.5 moles hydrochloric acid in enough water to make a 2.5-liter solution. What is the pH of the solution? The pK of CH3COH is 4.75. Guys, what I need you to keep in mind is a buffer. I know it's like got this really big definition where it's like, oh, a buffer is an equimolar mixture of a weak acid and its conjugate base. And then when you see the word buffer, it kind of freaks people out because they're like, oh, it's this special solution. Guys, what I need you to keep in mind when you're doing pH calculations, a buffer pH calculation is no different from any random acid and any random base pH question. Okay, so when you do a buffer question, I would need you to try to keep yourself calm and oriented and keep in mind, I know it's a weak acid, I know it's its conjugate base that can resist changes in pH and has equal moles. But guys, put simply, a buffer has an acid in it and then it has a conjugate base in it. Or it has any base in it. Yeah, that's all you need for the pH calculation. Okay? The only difference is because they've given you the Ka of the acid, which they need to do because it's a particular acid and its conjugate base, is you need to frame your equation very, very carefully. The one difference I do want you to keep in mind is when you're mixing any two chemicals normally, you're like, oh, write the neutralization equation, figure out what's left over. The difference here is though, you don't want to just deal with the hydrochloric acid. I need to figure out um how much of the conjugate base is there. Yeah. So buffer questions can either give you the acid and the conjugate base straight away, which means it's really easy to set up the question. Alternatively, before you get to the buffer equation, you need to figure out how much of the conjugate base gets made. Yeah. So what I mean by that is this. We'll do question 24 after, but I want to show you very quickly the difference. Yeah. Question 24, they mix acetic acid with sodium acetate. Acetic acid is the acid, sodium acetate is a conjugate base. The two components of the buffer are already given to you, so you can go straight into the buffer chemical equation. The difference between 23 and 24 is with 23, they give you sodium acetate, which is the conjugate base, and then they've given you the hydrochloric acid. There's going to be a neutralization reaction that happens first. You need to get the acetic acid, which is the other component of the buffer. Otherwise, you don't have what you need. Yeah? So your equation is for the acetic acid buffer, which is CH3COOH aqueous plus H2O liquid turns into CH3COO minus aqueous plus H3O plus aqueous. Yeah. Question 24, they've given you information for acetic acid and acetate. You pop it straight in. The only issue is here though, acetate and hydrochloric acid. There's going to be a reaction prior to the buffer that makes some of this, because right now you only have number for this one. Okay, so let me move up a little bit. So you've only, so far, what they've given you is this with your HCl AQ. This is a base strong acid equation, so it's just going to be a regular neutralization reaction. Yeah. This gives the hydrogen that way. So that becomes CH3COOH AQ. Okay. So with normal neutralization reactions, acid plus base turns into salt plus water. This isn't a regular base though, there's no hydroxide here. So you're just going to do your Bronsted-Lowry definition. The acid gives away the hydrogen, the base takes it, and then you'll end up with the leftover Cl minus on the right. There's no water here because it's not an Arrhenius base, there's no hydroxide. Okay, so I'm applying the Bronsted-Lowry definition. Yeah. So now, again, you need to figure out the acid component, otherwise the buffer hasn't been made. Otherwise, you don't have every component of the buffer. So how much do we have at the moment? You have 0.9 moles of this, and then you have 0.5 moles of this. Again, similar to the previous questions, if you're going to figure out how much product gets made, you need to know the limiting reagent. Guys, it's already a 1-to-1 ratio, so you can compare the moles directly. Just tell me which one's the limiting reagent. It's the HCl. Now, by the way, even if you didn't compare the numbers, This is a buffer question. Can the CH3COO minus be limiting? No, okay. Because like you need both components to be in the buffer. Yeah. So like right now you have this component of the buffer missing. It doesn't make sense to make this and then lose this. And then if that happens, you just replace one component of the buffer with another. You can't replace it, you need both. So we compare the numbers to be sure, but it's definitely the HCl. You can't lose the CH3CO minus because it needs to be in the buffer. It's a 1-to-1 ratio. If this is your limiting reagent, then 0.5 of it goes away, the whole thing. And then zero point 0.5 of it will react with the CH3CO minus. So then, guys, how much CH3CO minus do you have left to go into the buffer later? 0.9 minus 0.5 gives you 0.4. Yes. And then the amount of product that gets made started off at 0 because you didn't have any of it yet. The amount of product that gets made depends on your limiting reagent, which we've already said is 0.5 of the HCl. So then 0.5 gets made, and then you'll have 0.5 of CH3COH. Now you have both components of your buffer. Okay? So moral of the story is buffer pH questions are the same as any regular pH question. Just watch out for if you already have both components of the buffer or you need to go find it first. Once you've got it, you just pop it straight into your ice table the way you normally do. Yeah? You've got both components now. Um, Ice table takes concentration, so I'm just gonna turn it into a concentration. It's 2.5 liters for the whole thing. So your concentration of CH3CO minus N on V 0.4 divided by 2.5 liters. For the acetate, you will get 0.160. And then for the acetic acid, CH3COOH, you'll get 0.5 divided by 2.5. And then that'll be 0.2. Yes. Okay. You've got both components now. You pop it straight into the ice table for this. All right. So the standard buffer question will start here with what you see on the screen. The only reason we had extra to do was because the question was framed differently and you didn't have both components of the buffer yet. Yeah. Now that I've got, I'll pop it straight in. It was 0.2 for your acid and then 0.16 for your conjugate base. 0 for your hydronium because it hasn't dissociated yet. Because you don't have any product at equilibrium, you need a mixture of everything. So I'm going to shift to the right to make some of that product. And X. Once you've got everything in your E row, your equilibrium expression takes equilibrium concentrations. So once you've got all of your equilibrium concentrations, pop it straight into your equilibrium expression. CH3COO minus H3O plus divided by CH3COOH, which is 0.16 plus X with another X divided by 0.2 minus X. And guys, they didn't give you Ka, they gave you pKa. But in a previous question we did, you guys helped me convert between pH and hydronium concentration. You convert between pKa and Ka the same way. All right, so think back to how you converted to hydronium concentration for me. Tell me what's Ka equal to, if that's the pKa. Exactly, good. So pKa is negative log base 10 of Ka. If you rearrange this, Ka, you'll get the base 10. It'll be minus pKa, which is 10 to the minus 4.75. Thank you. So the minus goes in the power. You don't have a minus at the front. So then this is going to be 10 to the minus 4.75. And then, guys, that's a really small number. If you assume X is negligible anytime it's in a bracket with another number. Yeah? Which happens twice in this case. I'm going to leave this X on its own, but you make the assumption anytime it's in a bracket with another number, I'm going to do it twice. So X is way smaller than 0.16. X is way smaller than 0.2. So this is approximately 0.16X on 0.2. which is 10 to the minus 4.75. And then rearrange it to get x, 10 to the minus 4.75 times 0.2 divided by 0.16. And then what you get for x is going to be 2.22 by 10 to the minus 5. This is an acid equation. They want pH. We're going to get pH straight away because from your ice table, X was H3O plus. So it's not like it's a base and then you have to calculate pOH first. Luckily, you go straight into pH. Negative log base 10, 2.22 by 10 to the minus 5. And then this buffer is about 4.65 to 3 sig figs. Okay. So, moral of the story, do a buffer pH calculation the way you do any pH calculation. Just watch out for any prior steps you have to do because if you don't have both components of the buffer yet. Yeah, otherwise you just start straight here. Okay.